Hello all. So our project aims to build a machine learning model to predict soil saturated hydraulic conductivity, and our target variable is Ksat, which stands for saturated hydraulic conductivity. So the workflow involves data cleaning, feature selection, model training, hyperparameter tuning, etc. So our first step is data loading and understanding, in which we have loaded the data. We have understood that how many rows are there, how many columns are there, how many missing values are there. We have also seen the data types. We have also described the data. Now there were some unnecessary spaces which we have removed from the columns and then again displayed the result. Uh, this part shows that what percentage of missing values are there in each of the columns. So as we saw the raw data, in our raw data there were some unnamed columns which we have deleted because they were not consisting any of the content. So here we have removed the unnamed column. Still, when we saw the raw data, we know still there were some of the columns which didn't have the values. So moving ahead, we will handle those. So these are the missing values. So the columns which have missing values more than 99%, we have removed those columns and we have kept which has less percentage of the missing values. And so this is the part of the data cleaning. So for the some of the missing values we have imputed with median, because there are so many missing values and we couldn't remove that, otherwise there was no content in the target variable. And then we have imputed categorical columns with the mode. Now before proceeding further, we have done baseline model, which I can say is before pre-processing. So here I have considered numerical columns and have seen that how linear regression model works here. So we could see that RMSLE is 0, which is perfect, and R square is almost 54%. So our linear model explains 55% of the variance. Now we move to EDA. So here we have made histogram of our target variable and log Ksat. Why log Ksat? Because we wanted to, because we saw that this distribution of Ksat was skewed. So we tried to logarithmic it, and then we did box plots for Q numeric features to see how many outliers are there, and we can see that there are many outliers, and we have handled it later on. Then we have seen correlation heat map. There are correlations which we have handled later. Then we see the pair plot for the selected features. So here we can see that there are some multicollinearity in our features. So these are some actionable insights: that Ksat is highly skewed, clay percentage, it contains outliers, and there are some multicollinearity, etc. Then we move to data preprocessing. So in data preprocessing, our first step is outliers, and we have seen that there are many outliers. We have used in EDA we have used box plot technique. Here we have used IQR technique, and after that, instead of removing the outliers, we have used Winsorization, that is capping the outliers. And after that, we have seen that what is the original Ksat distribution and what is the log transformed Ksat, but we didn't see much difference because the value of Ksat is all very close to 0. Then I have applied min-max scalar, and after that also we can see there is not much difference. So then the next option was box cost transformation or power transformation. We chose power transformation, and we could see that somewhat it has become normal. So we can say it is a Gaussian distribution. Then third, we went to feature selection. So for feature selection, we used VIF scores and correlation matrix. And now the thing is that in DepthCM we are getting NaN, which means that there is no variance, because what we saw the raw data and the all values for the depth was 50. So we had removed that column also. Then according to our VIF scores correlation matrix, we have selected some of the features. Then again we have ran the baseline model after pre-processing, and here we see that RMSE is 80, and R square is 37. To enhance it further, we move to feature engineering. So here we have combined some of the features and made new features, and we have also done some binning here. And texture class was categorical, so we did some one hot encoding here. And so this is our feature engineering. Next, we have plotted 10 most important features, and here we can see that sample height is a most important feature. Yes, here domain knowledge works, and what we have read, that sample height do matter the most when coming to soil KDA. Then again, after feature engineering, we have run the baseline model, and we could see that there is not much improvement. So R square is 41, so the model explains 41% of the variance, and RMSLE is 0.07, which is very low error on a log scale, which indicates great prediction, stability, and minimum log scale underestimation. Then we may move to our main part, that is model training. So first we have scaled the features, and then we have split the data set into 80-20. So 80% goes to training and 20% goes to testing. And after that, we have ran several models like random forest, gradient boosting, ridge, lasso, SVR, K-neighbors, decision tree, ADA boost, elastic net. And after that, after training all models, we have seen that for the random forest, the R square was almost 50%. So here 50% of the variance was explained. So in this case, we could say that R square, in this case, we can say that R square, random forest is best model. But just wait, we went ahead and we did cross validation. These are the results for the cross validation. Next, we also wanted to try a neural network, so we tried MLP regressor, but unfortunately we didn't get the desired results. So next we moved to we actually assembled two of the models, RF plus Ridge, and here also we see that is there any improvement. So we can see that R square is almost like nearly 50%. And then out of this, we had used K. Next model that we have used is select K best. And so here we are using it without polynomial features. So what we thought was, let's introduce polynomial features. So it is before polynomial features, so R square is almost 50%. But when we introduce polynomial features and then we combine rich SVR random, there is slightly improvement in R square. So it's like 52% of the variance. But again, now we again tried select K-best model with polynomial features, and here we get good score, that is R square 57%, around 57% of variance was explained here. Then next we move to line charts and SHAP values. So here this is our SHAP summary plot, and this is our lime explanation. So in SHAP summaries plot, we can see that sample height is the most influential feature among all top interactions. And in lime plots also, what was a key takeaway is the model lowered the prediction of the sample due to low sample height. These are the features. The only positive driver was moderate slit percent here. Next, we move to hyperparameter tuning. So here we have chosen randomized search for hyperparameter, and till now we have selected our best model is select k, so we have done hyperparameter on our best model. So here we can see that there is not much improvement in the hyperparameter. Still, our best model is select k with polynomial features. Next, we also ran ridge and lasso regression and saw that how, that is there any improvement in the matrices, but there was not much improvement. Then we moved to subset experiments as asked in the question, and we ran 50 trials, and this is what we got. So this is the final subset experiments that we got. Okay. Okay, so we can say that highest average, this is our interpretation, that highest average R square is 13,000 samples. However, smaller subsets show high variance, and RMLC improves slightly at medium sizes here between 13,000 to 20,000. Next, we have also analyzed or visualized R square and RMSLE. So this was the plot for visualizations, and after this is the feature importance across the subset sizes. Now, what does this graph say? This shows that what is the importance of a key feature, and how it varies across different subset. So we can see that one of the most consistent and influential features is porosity proxy, which steadily became dominant as the dataset size increases. Similarly, we can see the clay high, and we can see the bulk density. On the other hand, there are some samples like sample aspect ratio, very coarse, or texture sandy. They are like fluctuating importance. So from this, we can conclude that porosity proxy and clay high may improve the model further. Now, this is our conclusion. So from here, we say that our best model is select k best with polynomial features. So our model explains 57.3% of Ksat variance, which is a very strong performance for real world regression in soil, for the soil, and our RMSLE is 0.07, which is which is small error, log scale error, and which indicates greater predictive stability. So thank you.